So now we're going to have a look at another question from the 2020 Advanced Maths HSC. So this is the last question in the paper. This is question 31. The population of mice on an isolated island can be modeled as the following function. So we're told m, mice as a function of time, is a times sine of pi on 26 times time plus b. Find a and b. So we can do this from the graph included. A is going to be the amplitude. So this will be how high and low the sine wave goes above its center. The center we can tell is at 20,000 because the lower point is 5,000, the upper point is 35. So 15 up to 35, 15 down to 5. So the amplitude must be 15. So A must be 15,000. And b is the center point of that function. It's the line about which the sine function oscillates. This will be the 20,000. So we will get mice as a function of time is equal to 15,000 times sine of pi on 26 times time plus 20,000. So really easy, 2 marks. You'll get 1 mark for finding one of the values, the other mark for finding the other value. So this is 31A. Now 31B, we are told on the same island the population of cats can be modelled. So C of t is minus 80 times cosine of pi on 26 times t minus 10 all plus 120. Consider the graphs. For what values, find the values for which both populations are increasing. Okay, so we're going to graph these two functions. So we have cats. We'll just draw them on the same graph. We'll essentially make it a non-scaled graph. So we really just need a picture of what these curves look like. We don't need them to be perfect though. So mice we know starts at 20k, goes up, goes down, goes back up. So this is t is 52. So it increases here, decreases here, decreases here, increases here. This is 39. This is 26. This is 13. So these are the points at which the function changes somehow. And then cats, c as a function of t, minus 80 times cosine, pi on 26, the same constant in front of time, but now the time is shifted. So this whole function is centered around 120. It's the cosine function, but it is shifted. Now, if you remember your shifts, a positive value shifts, so t plus something shifts you to the left, and t minus something shifts you to the right. So this is going to start at 10. The cosine will start at 10. So it'll be minus 80 times 120. It'll start at 140 at 10. And then it will move in increments of 13. So we'll go from 10 to 23. And then from 23 to 36. And then from 36 to 49. Because it has the same period as the function above it, it's just shifted. So it will go down here, it will go down to 40, and it will go up to 200, plus minus 80 being the amplitude. So then it will return to 120 here, it will go up to 200 here, and then it will go back down to 80 here, and then continue on back down. Now remember, this is not to scale. Not to scale. These are not perfect drawings of these functions. We're just using this to find when the populations are both increasing, right? So we know, if we look at our graph, that mice increase from 10 to 13 and from 39 to 52 between the span of 0 and 52. So these are the two mice increasing sections. The cat, they increase between 10, so we start increasing at 10, and then we'll go on until 36. So this is all increase. And the rest is all going to be decrease. The populations are actually going down at every other point apart from the range between t is 10 and t is 36. So we find that t included in the set 10 to 13 is the period where both are increasing. And this is the answer that we're after. So this is 3 marks. You will get 1 for some working that gets you towards an answer. In this case, the graphing of one function will get 1, the graphing of a second function will get the other, and then a correct statement of the range within which both populations are increasing. So in this case, it's between 10 and 13. We should correct this. This shouldn't be square brackets. It should be at 10, the cat population is not yet increasing. So it should be a curved bracket for 10. But then at 13, the mice population is no longer increasing. So it should be 10 to 13 with curved brackets, so not including 10 and 13, but the bit between 10 and 13. Right? The focus is finding over what region? Between 10 and 13. And this is the answer.